Hello and welcome back. This is the session on Java collections. More than often in our program, we need to work with groups of objects. Java provides us with three important types of collections. They are the list, the set, and the map. Let us begin our discussion by looking at the array class. No discussion on collections is complete without discussing arrays. Some of the characteristics of the array are: it is a homogeneous collection, that is, it has elements of the same type, and it is of a fixed size. Here we define a student array equal to new student of 2. 2 is the size of the array. Elements of the array are accessed by the index, and remember, in Java, index always starts with 0. If we have an array of size or of length 2, then the elements are indexed as 0 and 1. So, to access elements of the array, we use a simple for loop. We use a counter I, start from 0, and the condition is it is less than the length of the student array, and we increment it by 1. This counter will now serve as the index, and we use the student array square bracket of I, thereby making the counter the index value to access the elements of the array. So remember, the index is always length minus 1. A list is used to hold group of data. Unlike an array, a list is not of a fixed size and can grow in length. Assuming S1, S2, S3 and S4 are student objects, we define a list as list student list equal to new array list, and then we call the add method to add the elements S1, S2, S3 and S4. Here in this example, we add S2 twice. Please note, we define a list as list student list equal to new array list. A list is an interface and array list is an implementation. A list has many implementations like array list, linked list, etc. The array list implementation is more than sufficient for us for most purposes. We will look deeply into interfaces and implementations in the coming lessons. More of that later. But for now, you can safely say list name of the list equal to new array list. Now, Java has another way of declaring a list called a type safe list. We could also say list angular bracket student list equal to new array list of student. The student is given within angular bracket and is the class. Now, if we declare it in this fashion, student list becomes a type safe list. That is, it can contain only elements of type student. The previous declaration, list student list equal to new array list, can contain any Java object. Whereas the second declaration makes it specific that this list contains only student objects. And remember, a list allows us to add duplicate values. A list has several convenience methods: to let us know the size of the list, to retrieve the contents, add elements to list, or even check if a list is empty. For example, the isEmpty method will return a boolean value which specifies whether the list is empty or not. The get method allows us to access the element from the list using an index. So get of 2 will get the third element from the list. The size of the list gives the total count of elements in the list, and we use the add method to add elements to the list. A list is built for sequential access. A list can grow dynamically in size as opposed to an array that has a fixed size. The elements in the list can be accessed in two ways: using a for loop or using an iterator. The most standard way of accessing a list is using the for loop. First, we get the size of the list. we start with the counter the value of 0 and incrementing by 1 till it is less than the size of the list. This counter will serve as an index. We call the get method and pass in this counter value, which will allow us to get the element specified by the index. So the counter, in this case I, refers to an index value. Thus, using a simple for loop, we can iterate through a list and get the elements using the index notation. If we have a type-safe list, Java gives us a convenient method for accessing the elements in the list. For example, assuming we have type-safe list, student list, declared as list of student list equal to new array list of student, we can use a simple for loop for student, a variable, colon student list. So what happens is, when this for loop gets executed, each element of this list is copied into the variable s. And this is another convenient way of accessing elements in the list when we use type-safe lists. There is yet another way of accessing a list using an iterator. Calling the iterator method on the student list gives us an iterator object. Think of the iterator as like walking along a train. Each compartment is an element. Now you walk along until has next returns true, and once you want to get to the next element, you say the next. So an iterator is another convenient method of iterating or accessing a list. It is possible to convert a list to an array, and in this example here, the new student array size is the size of the student list. A set is similar to a list, but the important distinction is it does not allow for duplicate values. We define a set like this: set student set equal to new hash set. The add method allows us to add elements to a set. So how does Java prevent us from adding duplicates to a set? Java uses the hash code value to compare objects. And remember, we said if two objects are the same, then the hash code is also the same. And we made sure we implemented this when we overrode the equals method. When we had overridden the equals method, we made sure that we also overrode the hash code method using the same business key that was used in the equals method. So if two objects are equal, then the hash code should also be equal. So when you add duplicate values, by looking at the hash code, Java knows that they are duplicates, and thus it does not allow them to get added to the set. Let us look at a quick demo here. Here is the source code which I downloaded from the website. Let us first look at arrays. Here we have a student class, a student, the name, age, admission number, and a course. And there are some getter and setter methods. We had private, properties, and public getter and setter methods following the Java Bean naming convention. I also have overridden the equals method and also the hash code method. There is also a toString method present. So coming back to an array demo, what we do here is we create a student S1 equal to new student, S2 equal to new student, S3, S4 and S5, and we add some state, name, age, admission number. Then we define students. Look at the plural here, students. So we define an array of students. Students equal to new student of 5. The size is 5 here. Since we say the size is 5, the valid indexes are 0, 1, 2, 3 and 4. That is up till starting from 0 and up till size or length minus 1. So we assign the 0th element as S1, the first element as S2, S3, S4 and S5, so on and so forth. Then we use a for loop to access the elements of the array. We use a counter I and increment it by 1 until it is less than the length. And we use the index notation, square bracket of I equal to 0, 1, 2, 3 and 4 to fetch the student element. We could also use the new style for loop. We could say for student S is the variable, colon students. So for the elements in this array, as the for loop progresses, each element is copied into S and we print the contents of S. Let us do a quick demo here. I go to the root folder where I had downloaded the source. The source is downloaded in my folder. Okay. And then I have all the Java files here, arraydemo.java, listdemo.java, etc. So let me go to the command prompt and say java c star.java. This would compile all the programs in this current folder. So let me execute java array demo. Here what we do is we created 5 student elements, S1, S2, S3, S4, S5, and we added them to the array. We used a for loop to print the elements of the array, and we also used the new style for loop. It's a very simple example to help us get started with arrays. Please take your time to go through this code and get yourself familiar using arrays. Next, let us look at list. So in this example, we have S1, S2, S3, S4, and S5, again all students. Okay, and then we define a list as list student list equal to new array list. I have used type safe list here. In general, it is always recommended you use type safe list wherever you can. Once we define the list, we add elements S1, S2, S3, S4, and S5, and then we also add S2, S3, and S4 one more time. So totally there are about 8 elements in the list now. Then we access the elements of this list using a for loop with index notation. We start from counter I equal to 0, I less than the student list dot size, I plus plus. So we increment it by 1, starting from 0 till it is less than the size. And then we use the get of I, get of index notation, to get the elements of the list. Here is how we use an iterator. We say student list dot iterator. It gives us an iterator object, and using this iterator object we walk through the list. We get the next element using the next method until has next returns true. So this is a while loop. So let us run this example and see. Since the code is already compiled, I would just execute the program java list demo, java list demo. So S1, S2, S3, S4, S5, S2, S3, and S4. See the duplicates here. We said a list allows us to add duplicates, and here we are accessing them using a for loop. And here in this example, we are accessing the elements of the list using the iterator. Simple examples for you to go through and get yourself familiarized with lists. Okay, so good. Let us say we want to sort the elements in the list. How do we do that? Java gives us a comparator for sorting. First and foremost, I need to tell the list how to sort itself. For that purpose, Java defines us a comparator interface. A comparator is an interface which, what is an interface, we'll look into it later. But for now, suffice it to know that whenever you implement interface, you should have the method that is defined in the interface. We will look at interfaces in depth in the next 2 classes, but suffice it for now to say that whenever you implement a comparator, whatever method is there in the comparator needs to be implemented in your implementing class. So my class is student comparator and it implements comparator. Comparator has a method called public int compare and it returns you an int value. Using this int value, the list is going to arrange itself. For example, you're comparing objects obj1 and obj2. If obj1 and obj2 are both the same, if the let's say you're comparing on name, if the name is the same for obj1 and obj2, then this method will return 0. If obj1 is greater than object2, then this method should return a positive value, meaning the list can let itself be as is. If, on the other hand, if the object2 is greater than the object1, then the list returns a negative value. Using the positive, negative or 0 value, the list knows how to rearrange the elements. For 0 and positive, it does nothing. If it is a negative value, then it knows that the object2 needs to come before object1. So in this example, what we have done is we have implemented the comparator interface. So the public int compare method, it returns 0, a positive or negative value. Since in this example here we are comparing the names, we use the since in this example we are comparing names and name is a string class in Java already has a comparator method which will return you either a positive, negative or a 0 value depending on whether S2's name should appear before or after S1's name. So using this value returned from the getStrings, so using this value from the strings comparator method, we return either 0, positive or negative value. So in this example, since we are comparing the name, if both the names are equal, we should return 0. If the second object's name should appear after the first object's name, then we return positive value. Leave the list as is. But if the second object name needs to come before the first object's name, then we need to rearrange the list. In this case, we need to return a minus value. The comparator method on the string class does exactly this. So to make things easy for us, we know s1.getName is a string for us. So on the string, we call the compare2 method. So on the string, we call the compare2 method, which returns a value either 0, positive or negative value, depending on which should come after what. So once you define the comparator, what we need to do here is use the comparator in the list. Let us look at an example. We have S1, S2, S3, S4 and S5 as new students. And then we add S1, S2, S3, S4, S5, again S2, S3, S4. Now there are totally 8 elements in this list. And then using a for loop, we just print the elements. And then using an iterator, we again print the elements. All this is similar to the program we saw earlier in the list demo. Now comes the new part. We create a new object of student comparator. It's called myComp. You can name it anything you want. Okay. It says comparator and this is student comparator. myComp equal new student comparator. So student comparator is here. It's a class which we wrote just now, which will implement comparator. It has a compare method which takes 2 objects and returns an int value. The possible values are 0, positive and negative. If 0 means both objects are the same, if positive means the first object should appear after the second object, and if it is negative means the second object need to come before the first object. In this example, we are comparing names here. So what I have done here is I am using the names which is a string, compare to method. I'm comparing the names. So this method, compare to method, is actually a class or a method in the JDK library, which will return you positive, negative or zero value. So coming back to our discussion, we create a new comparator and then we say collections.sort. We pass in the student list and say my comparator. So what you tell the collections to do is sort this list using this comparator, and this comparator is based on name. And then finally what we do is we print the elements in the list. Okay, so let us run this example and see. Let me clear everything. I say Java list sorted demo. Okay, so let's go one by one. So this is our elements now: S1, S2, S3, S4, S5, again S2, S3 and S4, totally 8 elements. We print them using the for loop and using the iterator. Both values are the same. Now let us sort the list. We apply a new comparator and we say collections.sort. After sorting, what happens is we see that the elements of the list are arranged by the names. So sorting a list is really very easy, provided you implement the comparator. That is, you need to tell collections.sort on how to sort this list and how to sort this list. Here in this example, we are sorting the list based on the name. Time for us to look at the set demo. What we do here is, again, we create the students S1, S2, S3, S4 and S5. We create a new student set. Remember here it's a set, student set equal to new hash set. Earlier it was list, student list equal to new array list. Now this is a set now. And then we add S1, S2, S3, S4, S5. And again we add S2, S3 and S4. And then we access the elements of the set using the iterator. Simple, good enough, right? So let us run this demo. I say Java set demo. Before that, let me clean the screen. Java set demo. Okay, so we added Jack, Jill, Humpty Dumpty. We added Jill twice, but finally when we print the elements of the list, we see that Jill is printed only once. So in a set, we don't have duplicate elements. So in your programs, if you want to have a unique collection, that is, don't want to have duplicates, then the obvious choice for you is to have a set. And if you want to have a list and want to sort the elements in the list, you need to implement the comparator. So let us continue with our learning. Java gives us out-of-the-box algorithms to sort a list. The only thing we need to tell the sorting algorithm is to how to sort the data. We need to write a Java class that implements comparable and pass it to the sorting algorithm. The sorting algorithm then sorts the data in the list according to the conditions specified in the comparable implementation. For example, if you want to compare the students based on the name, this is how we do a comparator. We say public class student comparator, this is the class which we are writing, implements comparator. Comparator is the interface defined in the Java library JDK. So it has a method called public int compare object1 object2. What we do here is we use the names on the objects. Since we are comparing students, we are going to get the name of the first student and compare to the name of the second student using the default compare to method available in the JDK library. This method returns 0 if both values being compared are the same, a positive value if the right hand side is greater than the left hand side, else it returns a negative value. And depending on the value returned from this method, the list and the sorting algorithms know how to rearrange the elements in the list. So what we do here is we create a new comparator object and pass it to the sorting algorithm, saying collections.sort sort this list using mycomp. We saw a demo for this one. Time for us to look at maps. Java gives us a convenient way of organizing objects based on the key value pairs. The map interface consists of a set of keys and values corresponding to the keys. For example, let us say we had students and we want to arrange students based on the course. Meaning we want all the engineering students to be grouped together, the computer science students to be grouped together, and the medicine students or the management students to be grouped together. How do we organize data into groups? This is where maps come into play. Before we look at the example, let us look at the schematic representation. We want to have a representation like this. You want to have a key and a value, and the key would be, say, the course. In this example, computer science, and the value would be list of students in the science course. Medicine, and the value would be list of students in the medicine course. Key management, and value would be list of students in the management course. For example, this is how we organize data using maps. First and foremost, we define a map, saying map student map equal to new hash map. Remember we saw list student list equal to new array list, set student set equal to new hash set, and now we have map student map equal to new hash map. Then we iterate to the list of students using the for loop, and we get each student using the index value get of I, and then we get the course. This map called student map has two things, a key and a value. We first check if the course for the student has the key in the map. If the key is found, we get the value and add that student to that value, which is the list. If the key is not found, if the course is encountered the first time, what you do is we create a new list, add the student to the list, and put it in the map with a key and the value. Key would be the name of the course, and value would be a list with just that student. So let us look at the description, that schematic diagram, and then some visual representations to understand this better. Okay, let's say we have S1, S2, S3, S4, and S5 as student objects, and students are belonging to the courses management, computer science, or medicine. Now initially student map, which is a hash map, is empty. It has a key and a value. The value is the list of students here. Initially both are empty. So as we iterate the list, we first look at the student S1. S1 does not exist in the map. So what we do is we create an entry, key as management, and value is a list, and we add S1 to that list. Next, the next course is S2's course, which is computer science. We check if computer science belongs to this course. We check if computer science belongs to this map. Is there a key called computer science? No. So what we do is we create an entry, a key, the value is computer science. We create a key computer science, and the value is again another list, and we just copy S2 here. Next we look at S3. S3 is Humpty, who belongs to the course medicine. Does medicine belong to this map? No. We only have management and computer science. Medicine does not exist yet. So what we do is we create one more key called medicine, and the value would be another list having just the element S3. Here we go. Now we come to the element S4. S4, Mary, she has the course management. Does management belong to this map? Yes, we already have a key called management. Now what we need to do is, in this case, you need to extract the value for this key called management, which already contains S1, and add S4 there. Next we come to the object 5, Johnny, who again is in computer science. Does computer science exist in this map? Yes, we already have computer science. Jill is doing computer science. So what we do is, we get the value for this key, which is a list of students containing only S2 till now, and then we add again S5 as well. This way we have obtained a representation of the group data of students based on the course. The key is the course and the value is the students belonging to that particular course. The key is the course and the value is the list of students doing that particular course. Okay, let's look at the example now. We say map, student map equal to new hash map. This is a declaration, and then we get each element in a variable called stud, and then we have course. We first check if the map contains the key course. Is management there in the map? Initially the map is empty. It will go to the else part, and what we do is, we create a new list, add the student S1 into management, and then we put management S1. Next we come back and we say computer science is the course. Does this map contain computer science? No, not yet, only management is there. So go back, create a new list in the else part, add S2 to the list and put computer science as the key and the value as this list. Similarly we do it for medicine. Medicine would not yet exist in this map. So what we do here is, we do create a list, add the student S3 to that list, and create a new entry in the map saying course is medicine and student list contains S3. Student comes in, the course is again management. Now, is student map contains the key course? Yes, it already exists. So in this case what we do is, we get the list using the map.get of course, map.get of key. The key value is the list here, and that list we add S4. Similarly for computer science, which is S5's course, student map already contains the key computer science. We get that list, add S5 to that list and put it back into the map. This is how we use maps for organizing data. And this was a schematic representation, and this is how we added elements and thereby organize the data. Now if you want to have only those students who do sciences course, you can say, assuming sciences is a key in the map, you can say student map.get of key. This will give you a list, and that list you can print or operate upon. Let us look at a quick demo for this maps. We have S1, S2, S3, S4 and S5 as student objects. Remember, if you look at these examples, we are reusing the student objects again and again. The purpose here is to keep the examples neat and simple so it's easy to understand. Now, I add the students to a list, S1, S2, S3, S4, S5 added to the student list. Then what you do is, since you want to organize the data into maps based on the courses, we create a hash map, and this hash map has a key which is a string. The value is a list of students. Okay, so map course map equal to new hash map, and the key is a string and the value is a list of students. We iterate to the list using the for loop. We first get the student and then the course. We check if the course is there in the map. In our example, the first course is management. Management contains key. Does the map contain management key? No. So what we do is we create a new list, add the student to that list, and then put it into the map. We create an entry here. So management is created into the map now. The next student is computer science, belongs to the course computer science. We check here if computer science belongs to this map. No. We create a list and we create an entry in the map with the key as computer science. Then the third student belongs to the course computer science. We come to the map. Does the map contain computer science? Yes, it does. We first get the list value which is already there from the map and then add that student to the list, and then we put it back into the map. This is how we organize data using maps. And then once we are done, we can print all the elements in the map based on the key. To get only computer science students, I would say map.get of key, which is computer science here. Then if I want to get only the keys, I would say key set. On the map I call key set. This will give me the list of keys in the map. So let us run an example here. Executing this example, map demo Java map demo. Okay, so we had adding a new course, management studies, added a new course, computer science, and then computer science student already exists in the map, so adding list of students, then adding new course, medicine, and then fifth student was again management studies, so it already existed, adding that list to the existing management student list. And that is how we had computer science students Jill and Humpty, management students Jack and Johnny, and medical student Mary. And the distinct courses were management, computer science, and medicine. So this is how we organize data using maps. A map is a very powerful collection that you'll be using time and again in your program. A solid understanding of organizing data using maps will place you in a very high league among Java developers. Okay, time for self-evaluation. Number 1. Why do we need collections? What is an array? List some drawbacks of the array. Number 1. We need to know the type in advance. Number 2. We need to know the length in advance. Why do we need a list? What are the features of the list? A list is like an array, but it can grow dynamically in size. And a list supports duplicates. Accessing elements of the list, when to use a for loop and when to use an iterator. We use a for loop when you want to read the elements from the list, and when you want to operate on the elements in the list, like adding or removing elements, we use an iterator. What are different list implementations in Java? Array list, linked list are some of the implementations in Java for lists. How do we avoid duplicate elements in the list? By using a set instead of a list. How to sort elements in list? We use the comparator interface. The comparator interface tells the Java sorting algorithms on how to sort the list. The comparator interface is implemented by our own code which we write. In this example, we wrote the student comparator and then we compared using the names. We then gave this comparator to the sorting algorithm, say using collections.sort, name of the list to sort, and how to sort. How to organize objects? We use a map to organize objects by using a key and a value. What is a key? A key is a unique identifier for a group of objects. How to access elements based on the key? On the map, you say map.get of key. How to get the different keys from a map? We say map.keyset. gives us a set of keys. And then we also saw at a good coding principle, we should always declare variables as interface types and not concrete types. Remember, we said list student list equal to new array list. We didn't say array list student list equal to new array list. We said set student set equal to new hash set. We didn't say hash set student set equal to new hash set. So this is a good programming practice, and what this will buy us we will see in the coming lessons. For now, always remember, it is always better to use interfaces while defining a variable. We say map student map equal to new hash map. We do not say hash map student map equal to new hash map. So a good programming principle is define variables as interface type and not concrete types. If you are able to understand this for now, please leave it alone. We will look at it in more detail when we come to interfaces and implementations. Here are some assignment questions for you. Create an employee class with attributes employee number as integer, name as string and department as string. Implement toString method and equals method. Create 6 instances of the employee class and set the values for the employee number, name and department. Allowed values are HR, marketing and engineering. Make sure you have 2 employees belonging to HR, 2 in marketing and 2 in engineering. Create an array and add objects to the array. Create one more employee object. Set the values added to the array. What happens? Create a list in Java. Define variable as interface type. Define it as list, name of the list equal to new array list. Do not define it as array list, name of the list equal to new array list. Now add all the 6 instances created in step 2 into the list. Access the elements of the list and print the values. Create one more employee object. Set the values added to the list. What happens? Add duplicate elements to the list. Now print the values. Does the list allow for duplicate values? Now convert this list into an array. Create a data structure that will allow us to not allow duplicate values. Print the elements to make sure that there are no duplicates. Here you should use a set. Write a program to sort the employee objects in descending order of the employee name. And finally, organize the employees based on the department. When I need to access the marketing personnel, I should be able to retrieve only the marketing personnel without going through the entire list. Use maps here. I hope you enjoyed the lessons. We'll see you soon.